Algebra 2. Long time no see. We're going to start this week on simplifying radicals, or as I like to call it, hacking square roots to pieces. So this is the first worksheet I handed out today. We'll do problem number 1. And we've got the square root of 192. And the idea here is we want to break this into as many small pieces as possible and see if we can find a perfect square number that we can bring outside of the square root. So anybody that's into audio knows that 192 can be broken up pretty nicely, actually. It ends up being the square root of 2 times 96. Then 96 can break up into, bring that 2 down, 2 times 48. And I happen to know that 48 is 4 times 12, so that's helpful. We have 2 times 2 times 4 times 12. Now I know 4 is a perfect square, so let's take its square root and bring it out to the front. Square root. Okay, so that one's taken care of. Now, I also know that 12 is 4 times 3, so let's break that up into 4 times 3. This 4 can also come out as a 2 in the front. And we're left with 2 times 2. Oop. Look, we found a pair here as well. 2 times 2 is 4. So this pair can come out as a 2 in front. So all we're left with is this 3 inside the radical. So outside the radical, we have 2 times 2 times 2, otherwise known as 8. And inside the radical, we just have this 3 left over. So the answer is 8 square roots of 3. All right, slide this up there. Let's see, number 2, square root of 45. Number 2, root 45. Now, again, we're going to try and break this up into smaller parts. I know that this is divisible by 5, so let's see what happens there. It's going to end up being square root of 9 times 5. Well, look, I've already got a perfect square number that can come out. That's going to be square root of 9 is 3. So that can come out as a 3 in front of the radical, and all we have is left is a prime number, which is 5. So the final answer is going to be 3 square roots of 5. All right, let's do number 3. We have root 20. Let's see, number 3, square root of 20. Now it's good to think in terms of when you're dividing these numbers up. If you notice that the number is divisible by a perfect square that you know, like is divisible by especially 4, 9, and 25, that's kind of a gimme. I know this is divisible by 4, so that's where I'm going to start. So this is the same as the square root of 4 times 5. And I know that 4 is a perfect square. That can come out as a 2 in front of the radical, so that's going to be 2 root 5. All right, number 4. Square root of 144. Well, hopefully you know right off the bat that 144 is the square of 12, but just in case you don't, let's break this up into some prime factors here. 144 would be 2 times 72, and then 72 is 2 times 36, and look what we have here. We have 2 times 2, which is going to be 4, so that can come out as a 2 in front of the radical. We have the square root of 36. That can come out as, so that's going to be 6. And we have nothing left inside the radical, so it's going to be radical 1. 6 times 2 is 12. So it's 12 times the square root of 1, which is just 1. So that just equals 12. So sure enough, the square root of 144 is 12. All right, let's get lined up here, sorry. Number 5. Let me scroll down on the screen here. We have negative, let's see, number 5. We have negative square root of 18. And remember I was saying before, if you can get it to where you're dividing this by a number that you know is a perfect square, that's kind of a gimme. And this is divisible by 9, so that's great. So we have negative square root of 9 times 2. That 9 is a perfect square, so it can come out. Its square root is 3, so we have negative 3 times the square root of 2. 2 is a prime number, so this is going to be our final answer. Negative 3 times the square root of 2. Number 6. We have negative 4 times the square root of 75. Now think of what number could divide into this that's a perfect square. 25 is probably a good candidate, right? So we still have that negative 4 times the square root of, let's change this into 25 times 3. And we know 25 is a perfect square. Its square root is 5, so we have negative 4. That 5 can come out to the front, times 5. Square roots of 3. Negative 4 times 5 is negative 20, and the square root of 3 comes down, so the final answer is negative 20, square root of 3. It's going to be a little bit, does it show up there? Yeah, it's going to be kind of messy. Let's just do this real quick, sorry. Because my crayon is showing through from the first one. Okay, so we've got, let's go down to number 9 here. We have 8, let's see, number 9. We have 8 times the square root of 392x. Now we know if that x isn't squared, then it's going to end up having to stay in the radical. So let's just kind of go from here. Let's take 8. Let's just kind of start breaking this up. I don't immediately know any perfect squares I can divide in that, but I know that 392 divided by 2 is 196. That could be written as 196 times 2 times x. And let's see if that breaks up even further. So 196 divided by 2 is 98. So we get 98 times 2 times 2 times x. And look, we have a perfect square here. So this 2 can come out. So we have 8 times 2 times the square root of 98 times x. And let's just keep breaking this 98 down. What's 98 divided by 2? But it's 49. So we have 8 times 2 times square root of 49 times 2 times x. And bingo, we've got another perfect square here. That's 7 squared. So let's bring a 7 out to the front. So we get 7 times 8 times 2 times the square root of 2 times x. And it looks like we're done here. We just have to simplify this. 7 times 8 is 56, and 56 times 2 is 112. So that'll be 112 times the square root of 2x. Okay. Number 10. Give some room here, good. We have negative 2 times the square root of 512 a to the 4th. Now this variable is being brought to an even power, so we know that we can take its square root just by dividing this exponent by 2. So let's start by just going, this equals negative 2a squared times the square root of 512. Now I happen to know that 512 is a power of 2, so let's use that to our advantage. Let's go ahead and see if we can divide this by 4. What's 512 divided by 4? That's 128. So we have negative 2a squared times the square root of 128 times 4. And we've already stripped off a perfect square number here, so we can take the square root of this and bring it to the outside. So it's going to be 2 times negative 2a squared times the square root of 128. Let's see if we can divide that by 4 again. Sure enough, we can. So we get 2 times negative, am I still on screen here? Yep. Times negative 2a squared times the square root of, and 128 ends up being 32 times 4. That 4 can come out. So now we have, let's bring this over here so we don't run out of room. Now we have, this 4 comes out as a 2. So we have 2 times, let's see, 2 times negative 2 times negative 2a squared times the square root of 32. And I know that 32 is divisible by 16, so let's break that up that way. So this would break up into 16 times 2. This is another perfect square that we can bring out to the front. So we're going to take its square root. 16 squared is 4, so it'll be 4 times 2 times 2 times negative 2a squared times the square root of 2. All right, this is getting to be quite a mess here. But let's just multiply these out. 4 times 2 is 8. 8 times 2 is 16. 16 times negative 2 is negative 32. So we have a negative 32. We have an a squared. And we have a square root of 2. So after all that rigmarole, we end up with negative 32 a squared times the square root of 2. How fun. All right, we're getting there. Let's do number 11. We have negative 8 times the square root of 16 n to the 4th. Okay, right off the bat, this n is being taken to an even power, so I can divide the power by 2 and bring that out. So it's going to equal negative 8n squared times the square root of 16. Well, this one's kind of easy, isn't it? We know the square root of 16, that's 4. So it would be 4 times negative 8, otherwise known as negative 32 n squared. So that was kind of a gimme. Once we pulled this n to the 4th out, we had a perfect square there, so that was that ended up being pretty easy. Number 12. We have negative 6 times root 256 k to the 4th. Okay, the k is being taken to an even power, so that can come right out. So this is going to equal negative 6k squared times the square root of 256. Now you may or may not recognize that 256 is 16 squared, but just in case you didn't recognize that, let's try and divide this by 4 and see what happens. So 256 divided by 4 ends up being 64. So we have negative 6k squared times 64 times 4. So that should be a little more apparent. 64 is the square root of 8. 64 is 8 squared, and 4 is 2 squared. So we can bring an 8 and a 2 out to the front. So it's going to be 8 times 2 times negative 6k squared. And then there's only 1 left in the radical, so it goes away. 8 times 2 is 16. 16 times negative 6 is 96. So this ends up at 96. Negative 96k squared. So that ended up being a perfect square, which is fantastic. All right, number 13. Am I running out of space here? Good. Number 13. Negative 2 times the square root of 144 x squared y squared. This one is probably going to be a gimme for you. 144 is a perfect square, and of course these are perfect squares. So we're going to take the exponent in half on both of these. Square root of 144 is 12, so it's going to be negative 2 times 12 times x times y, which equals negative 24xy. Hopefully that one's pretty easy for you. Okay, number 14. Well, we're fitting a lot on this paper. Saving trees. Wonderful. Number 14. Pow. All right, we have a negative 5. Square root of 72 u to the 3rd v. Okay, the v needs to be left alone, but what we can do here, first let's split this into u squared times u. By the definition, that's the same as u to the 3rd. So this is going to equal negative 5 times the square root of 72 u squared times u times v. And the reason I did that is because now I have an even power here, so this can come out. So this is going to be negative 5u times the square root of 72 uv. And I know I can't mess with those u's and v's because they're to the first power, they're not perfect squares. We know that. So we can just mess with the 72. So I know that 72 is 6 times 12. That's not going to help me. Whoa, well, 9 times 8 is 72. 9 is a perfect square. So let's do that. Negative 5u times the square root of 9 times 8uv. My u's and v's look exactly the same, it seems. Okay, now 9 is a perfect square. That can come out as a 3. So we have 3. Am I still on the sheet here? Yeah. 3 times negative 5u times the square root of 8 uv. Okay, so let's see. 8 can be split up even more. Let's go over here. So let's rewrite this. We have 3 times negative 5u times the square root. And let's rewrite that 8 as 2 times 4. Of 2 times 4 uv. 4 is a perfect square, so we can bring that as well. That comes out as a 2. That's the square root of 4. Times 3 times negative 5u root 2uv. And then we just have to simplify. 2 times 3 is 6. 6 times negative 5 is negative 30. We have a u that comes down, and we have the square root of 2uv. Okay, looks like we have 2 more. Let me scroll down here. And they're just all kinds of fun. Here we go. Number 15. Number 15. We have 5 times the square root of 245 x y to the 4th. And I first thought, well, first of all, we have an even power here, so this y squared can come out, or I'm sorry, y to the 4th can come out as y squared. Let's divide 245 by 5 and see what happens. 245 happens to be 49 times 5. So we have, let's bring the y squared out, so we have y squared times 5 times the square root of 49 times 5. And then we have the x that comes down as well. So 49 times 5, well, 49 is a perfect square. That can come out as a 7 in the front. So we have a 7 times 5 times y squared times the square root of 5x. 5 is a prime number. We can't factor that anymore. So this is as simple as we can get this. So we just simplify. 7 times 5 is 35. We have a y squared that comes down times the square root of 5x. And that is as simple as that one gets. Last one. If anybody knows how to play the drums, now would be the time for the roll. Number 16. We have 2 times the square root of 392 u squared v to the 3rd. I know right off the bat that u squared can come out as a u. I'm going to go ahead and split that v into v squared times v. Okay, so I'm going to bring a u out to the front. 2 times that brings 2 down. So times square root of 392 v squared times v. So now I can bring that v out to the front as well. So now I have 2uv times the square root of 392 v. Now 392, I know it's divisible by 2, but let's see if it's divisible by 4. That would be pretty convenient because then we can just bring the 2 out. So 392 divided by 4 happens to be 98. We're in luck. So we have 2uv times the square root of 4 times 98v. Of course, that 4 can come out as a 2. So we have 2 times 2uv times the square root of 98v. Now, I know 98 isn't divisible by 4 because 100 is divisible by 4. But let's see if we can, let's see what happens when we divide this by 2. So we have, let's see, square root of, well, 98 is 49 times 2. That's fortunate. So 49 times 2v. And we have this 2 times 2uv out in front. 49, fortunately, is a perfect square. So we'll bring that as a 7. So we have 7 times 2 times 2 uv. I wish they wouldn't use u and v because those are kind of interesting. Square root of 2v. And all we have to do is simplify here. I'll move it up here because I think we're running out of room. We have 7 times 2 is 14. 14 times 2 is 28. We have a u. We have a v. We have a square root of 2v. And that is our final answer for number 16. And I am going to go get a glass of water now. Good luck.